All right, guys, adding to our notebooks today, we're going to talk about writing linear equations or one equation story problems. We're doing that on page 11 and 12 in our notebook. And so looking at those pages there, we should have this cute little book. So hopefully we do. And then we should have this one on page 12. And these ones are all filled out, so I'm going to go through it with you one more time right here. So looking at this first half sheet here, when we want to write a linear equation, we do want to think a lot about how we talked about graphing them. So when we talked about graphing linear equations, we talked about how we might graph in one of three ways. The first way was y equals mx plus b, or like slope-intercept form. And when I'm thinking about it in terms of graphing, the m is my slope, and the b number is my y-intercept. And like that's super helpful for graphing, but for story problems, that's less helpful. They're not going to say, hey, the y-intercept is this. They're going to put it in a cute little story, and so you have to like dig it out of there. And so the things that you want to look for, first of all, hopefully they give you just two numbers, because then that'll make it real easy to know, like, okay, one of those numbers is going to be slope and the other is going to be the y-intercept. The slope number is going to be a number that happens over and over and over again. So I like to call it my over and over again number. So a number that's happening over and over again, that's my slope number. That's usually pretty easy to find. You can look for words that like for each or for every or constantly or rate or stuff like that. And then my y-intercept is like my starting point or my beginning number. Or really it's kind of like a one-time number, like it happens only once. So a really good example of a story that would use y equals mx plus b is this one here. So Rachel joins a CD club. She pays $15 for the membership and $6 for each CD she buys. So I always like to identify my over and over again number first. Usually that's the easier one to pick out. So because every CD is going to cost $6, I have to spend $6 over and over and over again. So 6x. And the reason that 15 makes sense as my y-intercept or my starting or my beginning amount is because I can't even buy the CDs unless I pay this amount to get in. So I have to pay $15. Also, it's a number that only happens once. I pay it once and I'm done. And right now we're just practicing writing the equation. So there you go. That's it. You're not going to do anything with it yet. You could go graph it because we talked about that last time, but we won't need to now. Now, another form that we talked about was point slope form. And I think I told you guys point slope form looked like y equals a, parenthesis, blah, 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 blah. I'm going to change it just slightly and go y equals m, parenthesis, x minus h plus k. Only to be consistent because that front number there is my slope number. M or a or whatever I call it, because it's being multiplied, it is my slope number. So that's going to be, again, my over and over again number. And usually that's easier to find. However, in point slope form, these next two numbers, so I have a total of 3 numbers, which is different than this one. So 2 numbers here, 3 numbers there. That's kind of a cheaty way to know. These two numbers kind of belong together. Now, graphically, they were like your point that you plotted first, but technically there are 2 numbers there. And it's not the starting number. It's kind of an example that happened later on where I did some stuff. So I kind of like to call this one one example or one instance of the story that kind of happened later on. So one example later. Like going back to Rachel up here buying her CDs, if instead they said that it cost $6 for each CD, and after Rachel had purchased 2 CDs, she had spent $27, that would be a good example of point slope form, because the 2 CDs and $27, they kind of belong together. It's like one example of the story happening later, not right at the start. Because I'm already in the club, I bought some CDs, and this is how much it cost me. So another example of point slope form, the relationship between converting degrees Fahrenheit to degrees Celsius is linear. It constantly changes by a rate of 5/9. When the temperature, sorry about my typo, the temperature is 50 degrees Fahrenheit, it is 10 degrees Celsius. Okay, so right off the top, I can see that I have 3 numbers, which probably means we're not doing this. We're probably doing something more like this. Another easy number for me to identify is the word rate is sort of telling me this is my slope number. So I can kind of start this off, y equals 5/9, parenthesis x minus, end parentheses, and then we're going to have to fill in 2 numbers here, which probably have to be the 50 and the 10, but the definitely confusing part of this is like which one's supposed to go first and which one's supposed to go second. So because they told me up here I'm converting Fahrenheit to Celsius, because I need to know Fahrenheit to go to Celsius, that sort of tells me Fahrenheit is X and Celsius is Y, because I need to know X first. Like it just goes in alphabetical order, like X then Y. And because I know Fahrenheit and I'm going to Celsius, I need to know X then Y, or F then C. I hope that's making sense. So because that's the case, we're going to go 50 first because that's Fahrenheit, and then 10 second because that's Celsius. And again, we're not really doing anything with these equations right now. We're just practicing writing them. And then eventually we're going to have to do stuff with them, like we were doing yesterday, like graphing, or the day prior where we were using 2 and solving, like finding where they intersected each other. Okay, last form is standard form. And if you recall, standard form was kind of no fun to graph, ax plus by equals c, because the numbers in place of a, b, and c kind of didn't tell me anything about my graph that was important, which is a bummer. Like we had to do some math to get the values that I need to be able to graph. Now the opposite is true for writing equations in standard form. Standard form is actually great for that because they can give you lots of information. So your A and your B are each slope numbers, like different slope numbers for different variables, which is so weird. So they are both over and over again numbers, or like slope numbers. They're slopes for different folks. Oh my gosh, that's cute. For different variables. But they are slopes for different folks. I like that rhyme. Which I remember being in high school thinking, like reading through story problems like this, and I'm like, but wait, I'm only supposed to have 1 slope. Why are they giving me 2 slopes? And I would always get so confused by that because I wasn't remembering standard form. Standard form lets you have 2 slopes for 2 different things. And then C is your total. So like they're going to have to tell you a total overall, and usually that number will be pretty obvious, okay? So a really good example of this, where I'm going to use standard form, is in a video game, you earn 5 points for each jewel that you find and 2 points for each star that you find. Write an equation in standard form. Look at that, they just tell you. That represents the number of jewels and stars you must collect to earn a total of 250 points. But even without them telling me, I kind of know that I need to use standard form because they told me a total. And so I know that that's going in for C. And also, 5 points for every joule is going to happen over and over and over again for joules. And 2 points for every star is going to happen over and over and over again for stars. So I have 2 over and over and over again numbers for 2 different things. And so one is going to be the A value, so like 5x, or I'm going to be real specific here, 5j plus 2s. And I like to use really specific variables like that because it will help me to remember later if I need to plug something in. Like if later on they tell me, okay, you earned 10 stars, how many joules do you need? You could plug in 10 here and figure out how many joules that you need. So that's why I like to use really specific variables. Okay, so the other thing that we went through in class that we didn't fully get through, but we can talk about here, are the examples in our beautiful book. Now, in both hours today, we did get to this first one here. So you're visiting Baltimore and you have a taxi company that is charging a flat rate of $3 for using the taxi and 75 cents per mile. Write an equation to find the total cost. So this would be a really good equation. Some of you really impressed me by putting y equals 3/4 x plus 3. Changing that decimal to a fraction, you know I love that. Okay, either one is good. So I could tell that it needed to be y equals mx plus b because that 75 cents per mile is going to happen every time I ting a mile. And $3 is only going to happen once, initially when I get into the car at the beginning. Now, the other stuff that's kind of important is to notice that they're telling you x is miles and y is cost. So when I go over and try some more problems that are related to this one, I can make sure I put the numbers where they're supposed to be. So how much would a taxi ride for 8 miles cost? Well, 8 miles, they're telling me that x is now 8. So I can take my equation and in place of x, put 8 and figure out what the cost will be. And I picked the one as a fraction because I noticed that I can really just throw this guy over 1 and do a little cross-cancel-y stuff because like 4 goes into 8 twice. And so really this is just 6 plus 3 for $9 total cost. And then the last example here, part C, if a taxi ride costs $15, how many miles did the taxi travel? So now they're giving me cost, which they said y was cost. So going back to my original equation, we have 15 equals 3/4 x plus 3. And so we'll subtract 3 on both sides. So 12 equals 3/4 x. And then to get rid of that fraction, I felt like that was going to be easier to get rid of than a decimal. I'd have to divide by a decimal, and that sounds like an awful idea. I'd rather multiply by the reciprocal because, again, I can do a little cross-dividing stuff. Like 3 goes into 12 4 times, and 4 times 4 is 16 miles, not dollars. Cool. Cool. Okay, let's try another. Sorry, I had a brain fart there. I was like, did I do that right? The other one that we talked about briefly in class was this point slope form one because it was a little bit different. So we said the math department sponsors a math family fun night. Sounds like a lot of fun, guys. We should do this. In the first year, there were 35 participants. And in the third year, there were 57 participants. So like if you glance too quickly, you might think that there were only 2 numbers here, the 35 and the 57. But on further inspection, it's actually there are 4 numbers, which also isn't great because like all my examples over here use 2 or 3 numbers. None of them use 4 numbers. But if we read a little bit more carefully, I can say that X is years and Y is participants. And so really what I have here are 2 pairs of things. So like 2 ordered pairs. Where in the first year, I had 35 participants, so they kind of order up and pair together. And in the third year, I had 57 participants, so they order up and pair together. And that's helpful because if I have 2 points, then I can find the slope. Normally, we talked about graphing and counting like rise, run, but this is a lot to graph. So instead, we can use our formula, which was y minus y over x minus x. And they're actually stacked in a way where I can kind of just subtract right now. We just want to be careful because x has to go on the bottom. So like 1 minus 3 is negative 2. And 35 minus 57 is negative 22. And so when I divide, I get that I had 11 participants join each year, because that's what we're dividing here, participants by years. And now that I have that slope, I can write this in point slope form, so that y equals m, parenthesis x minus h plus k, excuse me, because I have the slope. And I really have 2 points that I can pick from. I can pick the first year or the third year, either one. So y equals 11, parenthesis x minus 1 plus 35. Or I could have written it y equals 11, parenthesis x minus 3 plus 57. Now with this one, it's a little less confusing about the, like, compared to the Fahrenheit and Celsius, because they told me that x had to be years and y had to be participants. But also, I kind of need to know what year it is before I know how many participants there will be. So that's why years has to come first. And so then the last one here, they're going to give you a value to plug in. So how many participants are predicted in the 5th year? So they are telling me a year, which goes in for x. And I'm going to pick that top equation just because they're smaller numbers. So we're going to do 5 minus 1 plus 35. So I just need to simplify here because all the stuff is together on one side. So we'll do what's in the parentheses for 4. And then multiply for 44 and add that to 35. So we can guess that there will be 79 participants in that 5th year if we stay at that current rate. Okay, then last but not least, the one we definitely didn't get to in either hour, but we're going to talk about standard form. So the fisherman's market has shrimp that sells for $4.25 a pound and halibut that sells for $2 a pound. You have $11 in your wallet to pay for your purchase, okay? So the per pound thing for 2 different things is kind of showing me those 2 different slopes. So $4.25 for every shrimp and $2 for every halibut. And I have a total of $11. So I'm actually not going to do what they're saying here, X is shrimp and Y is halibut, because I want to use smart letters. So I'm going to do 4.25 S plus 2H equals $11, because that's all I can spend. That's all the money I got. $11 is my total. If you put X and Y, that's fine too. Part B, what is the slope of the line? What does it represent in the context of the problem? Well, right now, this is in standard form. And standard form doesn't show me the slope. I have to be in one of the other 2 forms. And kind of the easiest form to get to is slope-intercept, y equals mx plus b. So keeping in mind, and I guess this is why we had to call it x and y, that halibut is y, we're going to solve for h. So we would want to subtract that 425. I'm going to change them to x's and y's now. And then I would divide everything by 2. And so we'd have y equals negative 2.125x. Ew, gross. Plus 5.5. Oh my God, I hate all this. I hate the decimals. And then, like, what does this slope mean in terms of the problem? Well, technically what I have here is the price of shrimp over the price of halibut. So it's like the price of shrimp per halibut. It's weird. Shrimp per halibut. If I crossbreed them, I don't know. It doesn't make sense. Question mark. It doesn't work anymore. So then part C, how many pounds of shrimp can you buy if you need to buy 1.5 pounds of halibut? So here's where I'm actually going to go back to our standard form because they're telling me I want this much halibut. So I'm going to put it in for H. So 4.25S plus 2 times 1.5 pounds of halibut equals $11. And I'm going to change that to 3 over 2 because I recognize the 2's will divide out. So we'll have 4.25 shrimp plus the 2's will divide out. You're left with 3 equals 11. Subtract the 3 for 8. And then we got to divide the 4.25. Oof. I should change that. I won't. It's like less than 2-ish. Round to the nearest tenth. All right, I'll divide it on my calculator. Y'all convinced me. 8 divided by 4.25. We want to round to the nearest tenth. So 1.9 pounds of shrimp. Who likes seafood anyways? Yuck. All right, I hope it goes well for you guys. We'll talk more about them tomorrow.